First thing it says, determine P of C using the remainder theorem for the given polynomial functions and value of C. If P of C equals 0, factor P of X into X minus C times Q of X. So remember from the lesson, it was saying that the remainder theorem states that evaluating and dividing is almost the same thing. And the reason being is because the remainder, when you evaluate a polynomial, is the same value of C and X minus C. If you plug that in, you're going to get the same remainder. So for here, it says for C equals 4, it's literally asking you to do P of 4. And so it's asking us, okay, well, if this works, if this gives me 0, so this is going to give me 2 times 16 minus 4 plus 1 equals 32 minus, what is that, 3? So that's going to be 29. Well, that wasn't 0. So because that wasn't 0, I can't factor it. So you would have to go through and check 2, 3, or 4 to see if it's going to give you a 0. And then you would just write it as, let's just say hypothetically I plugged in 2 and 2 worked. Then I would actually have to go through and use synthetic division to be able to go through and divide it. Just kind of like what we did in the previous lesson. It just means that if it is a 0, you can use synthetic division to go through and divide it. Alright, so number 5 says you're given a polynomial and one of its zeros. Use the techniques learned to find the rest of the zeros. Alright, so we have a 0, it's 1. So that means I can divide into my polynomial. So 1, negative 6, 11, negative 6. Bring down the 1, multiply, add, multiply, add, multiply, add. Well, remainder constant x squared. So this is a 0, right? That's what that means. So that is a 0. So I could write it as a factor of x minus 1. Now I'm left with x squared minus 5x plus 6. Well, this will factor into x minus 3, x minus 2. And so there's my factored polynomial. Now the one thing I want to point out for the next one, for number 7, it does say that 1/2 is a 0 multiplicity 2. That means you have 2 of them. It means you got to do it twice. So for 1/2, I just kind of want to point this out because it's actually really important. The coefficients, I have 4, negative 28, 61, negative 42, and then 9. Bring down the 4, multiply, add, multiply, and so 61, 51, 48. Multiply, add, what is that going to give me, 18? Negative, multiply, add. So it is a 0. It does work. Now, the issue here, though, is, yeah, I can write x minus 1/2, but I have to do this again. My recommendation is when you go through and you do this again, you're going to use this polynomial. You don't want to use the original again, because right now it's saying that there is another 1/2 as a 0 embedded into this. This statement here this represents another, basically that's our q of x, so to speak. Well, that q of x can still be factored further. And so you'd still go through this process, add straight down, multiply, add, multiply, add, multiply, add. It worked. Then I know that I have x minus 1/2 again. And so now your job would be to factor that further. The last little piece to kind of talk about here, notice how there's a 4 in common. So even though this is a remainder constant x squared, I can factor out that 4, and I'm left with x squared minus 6x and then plus 9. Because I factored out a 4 from each of those terms. This 4 is kind of essential, and typically what's going to happen is this 4 here is going to work in to what we need here, because writing it as x minus 1/2 is kind of improper. And so if we think of like, okay, well, what would I have to multiply by to kind of get rid of that 1/2 fraction? Well, it would be 2. Well, those 2's are here, right? 4 is 2 times 2. So you have to break this up. You're going to have to take that 2 and multiply it to there, take this 2, multiply it to this one. So this 2 for this one, this 2 for this one. And so when you multiply those 2's through, you're going to get 2x minus 1, 2x minus 1. And then this, that factors into x minus 3. So then you have x minus 3 times x minus 3. All right, here we go. Keep it moving. It says create a polynomial which has desired characteristics. You may leave the polynomial in factored form. So it says the zeros of my polynomial is plus and minus 2 and plus and minus 1. Okay, well, here's my plus 2. Here's my minus 2. Here's my plus 1. Here's my minus 1. And it says the leading term of your p of x has to have it 117. Well, let's check it. If I multiply 117 times x times x times x times x, well, that gives it to me. Boom. There's my answer for number 8. Now you're probably thinking like, whoa, well, you could do all these other things. You know, there's other possibilities. You're right. But it's just asking me to create a polynomial that just has those characteristics. So this polynomial that I've created at least has those characteristics, so it's going to work. All right, number 10. It says use the given information about theta to find the exact values of sine of 2 theta and cosine of 2 theta. So remember, these are double angle identities. So the sine of 2 theta is 2 sine theta cosine theta. And so it's telling me this is in quadrant number 4. What is that? Opposite over hypotenuse. And so you need to find what sine theta and cosine theta is there. And same thing with the cosine of 2 theta. You may have to look up the identity for what cosine of 2 theta is. And then once again, once you find the sine theta and cosine theta from that statement, then you can plug them in and simplify.